Good morning. Today I will be teaching about the constant rule in basic calculus. But first, how do you know if the number is a constant? Okay, we identify the number as constant if it doesn't have an x or it's a single number. For example, f of x equals 3. The number is constant. Or g of x equals 5. The number is constant because it does not have an x. If that's clear, then let's proceed to the example. For number 1, okay, f of x equals 7. If the function is constant because the number does not change. It is always 7 no matter what it is. The rate of the derivative is 0. Look at the formula. d over dx of 7 equals 0 because it does not change, or the number is constant. It does not increase or decrease. So the rate of change is 0. Number 2. If we will apply the constant rule, d over dx of negative 3 is 0. No matter what value the x we choose, since g of x equals negative 3, it will always remain as the value or the negative 3 since there is no change. The derivative is still 0. Lastly, example 3. This one is a larger constant. h of x equals 100. Using the constant rule, d over dx of 100 equals 0. Since hx is always 100, it will never change, so the rate of the change or the derivative is still 0. And that is how we apply the constant rule. Always remember, if it's a constant rule, the equivalent of the x or the derivative will never change. It will always remain the same value.
The second rule for finding the derivative of an algebraic function is power rule. For this rule, we will use the formula. The derivative of x raised to the power of n is equals to nxx raised to the power of n minus 1, where n is a real number. Here's an example problem number 1. The derivative of x raised to 3.
lesson, we are going to go over the constant multiple rule for derivatives. So, here's what you need to know.
The derivative of a constant times the function is equal to the constant times the derivative of the function. So all you need to do is find the derivative and multiply it by that constant. So let me give an example. Let's say if we want to differentiate 3 times to the 5th power. Now, the constant is 3 and the function of x is x to the 5th. Now, you can differentiate x to the 5th using the power rule. So, let's rewrite the constant 3 and let's take the derivative of x to the 5th power. If you recall, the derivative of a variable raised to a constant like x to the 5th is n times x raised to the n minus 1. So, that's going to the 5 times x raised to the 5 minus 1. Now, 5 minus 1 is 4. And now, we can multiply the 5 by 3. 3 times 5 is the 15. And so, this will give us 15 times to the 4th power. Go ahead and try this another example. Find the derivative of 4x to the 7th power using the constant multiple rule. So, the constant is 4, and we need to differentiate x to the 7th power. So, using the power rule, it's going to be 7x raised to the 7 minus 1. 7 minus 1 is 6, and then 4 times 7 is 28. So, it's going to be 28 times to the 6th power.
Another example for the constant multiple rule, we have f of x is equals to 5x cubed. So our goal is to take the derivative, so we separate the constant of 5. Then we take the derivative of just the cube part using the power rule. We bring n down, so when we bring n down, we bring the cube down. Then we subtract 1 from the cube, so we get 2. Then we multiply 5 and 3. So we get 15x squared.
So, that's a simple way in which you can use the constant multiple rule in order to find the derivative of a function.
Hello everyone, my name is Christine May Mansano, and today we are going to learn about the sum and difference rule in differentiation. These rules help us break down complex functions into simpler parts. Now, let's get started. So first, the sum and difference rule states that f of x plus g of x equals the derivative of f of x plus derivative of g of x and vice versa. Means that when we differentiate a function that consists of multiple terms added or subtracted, we can differentiate each term separately. So now, let's try an example. Here, we have f of x equals 3x raised to the power of 4 plus 5x raised to the power of 3 minus 2x squared plus 7x and then minus 4. Using the sum and difference rule, we differentiate each term separately. So, when we differentiate each term, we have to use the power rule. It is when we multiply the power like this, and we multiply the 4, which is a power, to the 3. As said earlier, we have to differentiate each term separately. So first, we're going to differentiate the 3x raised to the power of 4. The first, 4 times 3 is equals to 12. And then, you have to bring down the x. You have to always bring down the x, okay? And then, it is also a must to always subtract the power to 1. Okay? And we use the power rule. So, since 4 times 1 is equals to 3, we have to put 3 to here. So, it'll become 12x to the power of 3. Next, we have 5x to the power of 3. Just like we did on the last term, we have to multiply 3
5 is equals to 15. And then bring down the x, then subtract the 3 to 1. So it will become 2. So the answer would be 15x squared. Next is negative 2x squared. 2 times 2 will become 4. Then bring down x. Then minus 1. Okay? So since we all know that the value or the visible number beside the x is 1, we don't have to include that as 4x1. No, we don't have to include the 1. Oh, it is only 4x. Next, since, as I said earlier, since the visible number beside the x is 1, it's automatic that the answer will be 7. And since the x is a constant, it will become 0. In constant rule, it is said that a constant is equals and always equals to 0. So this term, negative 4, will not be included since it is also a constant form. So now next, we have to combine all the results that we got. So we have 12x to the power of 3 plus 15x squared negative 4x and then plus 7. So that's it. The derivative of this, let me just change it again. So, yeah. The derivative of this is this one. So let's go to the another problem. Okay, next, the process that we have to do on the second problem is just the same as we did on the previous problem. All you have to do is watch and learn.
How quotient rule works. For example, we have d over dx and 7x plus 4 divided by x squared plus 5. So how can we find the derivative of function in a fraction? So right here, we need to use the quotient rule for this problem. And here's the formula that we need to be familiar with. The derivative of f over g is equals to g prime times f minus f times g prime over g squared. So f is the numerator of the fraction and g is the denominator. So the f is equals to 7x plus 4 and the g is equals to x squared plus 5. F prime and g prime. F prime equals to 7 because the derivative of 7x is 7 and the derivative of constant 4 is 0. Meanwhile, the g prime is equals to x because the derivative of x squared plus 5 and the derivative of x squared is 2x and the derivative of the constant 5 is 0. That's why that's 2x. So by using the formula of the quotient rule, we have x squared plus 5 and 7 minus 7x plus 4 and 2x over x squared plus 5 squared. Let's remove this one. The first thing we're gonna do is distribute. So 7 times x squared is equal to 7x squared and 5 times 7 is equal to 35. And then 2x times negative 7x is equals to negative 14x squared. And then 2x times negative 4 is equals to negative 8x divided by x squared plus 5 squared. The next thing we're gonna do is we're gonna combine like terms. So 7x squared minus 14x squared is equals to 7x squared. And then we're gonna bring down negative 8x plus 35 divided by 2x squared plus 5 squared. Now, that's the final answer.
12. In the divisor, the number dividing the dividend. Example 3. So we will divide 12 divided by 3 to see the result of the division. So 12 divided by 3 is 4. So 4 is the quotient. For example, 15 divided by 3 equals 5. The quotient will be 5. For more example, 20 divided by 4 equals 5. The quotient will be 5.
Now we're gonna talk about the product rule for derivatives. So let's say we have the function of f multiplied by function g. Then its derivative will be f prime g plus fg prime. So let's say we have the given function of x squared sine x. We can notice that x squared is actually f since it aligns. Then our g is sine x. So we're going to find the derivatives of those. So for x squared, its derivative will be 2x, which is now f prime. Then for g, the derivative of sine x is cosine x. Now that will be g prime. So now we're going to substitute. So our f prime will be 2x, then multiplied by g, which is sine x. Then we're gonna add x squared, which is our f, then g prime, which is cosine x. Then we can still simplify this by taking out x. So we're gonna be left with 2 sine x plus x cosine x. Then for our next example, our given is the function of 5x minus 9x cubed multiplied by 8 plus x squared. So our f will be 5x minus 9x cubed and our g will be 8 plus x squared. So the derivative of 5x is 5. Then the derivative of 9x cubed will be 9 times 3 squared, which is 27x squared. And then the derivative of 8 is 0 since it's a constant. Then the derivative of x squared will be 2x. So when we substitute, we get this. Our f is 5x, f prime is 5 minus 27x squared. Then our g is 8 plus x squared plus our f being 5x minus 9x cubed. Then our g prime is 2x, and that will be our final answer.
Using the product rule. Today, we will find the derivative of the function f of x equals the quantity x squared plus 3x times the quantity 4x minus 5. Since this function is a product of two expressions, we will use the product rule, which states the derivative of f of x equals the derivative of g of x times h of x plus g of x times the derivative of h of x. We let g of x equals x squared plus 3x, x of x equal 4x minus 5. Now, we differentiate both functions separately. The derivative of g of x is g prime of x equals 2x plus 3. And the derivative of h of x is h prime of x equals 4. Now, applying the product rule, we substitute these values. F prime of x equals the quantity 2x plus 3 times the quantity 4x minus 5 plus the quantity x squared plus 3x times 4. Next, we expand the terms. Expanding the first term, 2x times 4x is 8x squared. 2 times negative 5 is negative 10x. 3 times 4x is 12x. 3 times negative 5 is negative 15. This is simplified to 8x squared plus 2x minus 15. Expanding the second term, x squared times 4 is 4x squared. 3x times 4 is 12x. Now, we combine like terms. 8x squared plus 4x squared is 12x squared. Then 2x plus 12 is 14x. And this is the final derivative. F prime of x equals 12l squared plus 14x minus 15. And that's my answer. By following the product rule step by step, I successfully found the derivative